Hello everybody, welcome back to the channel, and today I brought another math problem, or more specifically we have a geometry problem today. So let's try and solve it. So we have a triangle, as you can see, and what the problem wants us to do is find the length of the base, AB. So in case you don't know, AB is this side length here, and we want to find the length of that base. And then we have four answers, possible answers, and one of these will be the right answer. So A, 2.7 centimeters, B, 3.9 centimeters, C, 4.6 centimeters, and D, 5 centimeters. And we need to find what is the correct one. Okay? So let's start. So first thing, let's look at our triangle. It has three sides, like a triangle does. And these two sides here are the same side length. And the area, so the inside of the triangle, the area is equal to 11.5 centimeters squared. And then the two angles on the bottom here, since these sides are the same, is 65 degrees for each side, appropriately. And we want to figure out this side length here. Okay, so what first thing I'm going to do is I'm going to call the AB side length X. I'm going to call it X. And then I'll call the rest of the side lengths Y, because these two are the same side length, so I can just call both of them Y, and that should work. And now let's do some math. So we have the area, and if you know the area of a triangle, you would know that the equation for that of area of a triangle is area is equal to 1/2 base times height. So we can rewrite that with the variables we know. So we have our base, A is equal to 1/2. Base is X, right? What we want to know, times height. So height we don't know. I'm actually draw in the height. So the height is this part of the triangle. It's the distance from the base to the very top of the triangle. So our C point. And this, well, I'll just call it H for height. And we do not know what our height is, but this is written in our triangle's variables. So now I have this, but I have two unknown variables, so I cannot solve for anything yet. So let me do the next step, which is, you see this triangle is broken into two pieces, or you can break it into two pieces. You can break it in half, and I'm going to draw one of these halves like this. So imagine this A to X, the distance, would be just cut in half or taken as its own triangle. So we would get this part here. So our side here would be the length of H. Our side here would be the length of Y. And this would be 1/2 X, right? Because this whole thing is X. Half of the triangle, or this part of the smaller triangle, would be 1/2 of X. So now, 1/2 X, and this angle would be 65 degrees. Let me redraw the triangle to make it look a little nicer. Okay, so now we have this kind of triangle inside the triangle, but it has the same variables as this triangle. And we can use this to our advantage. So now we have our 65 degrees. So it seems like we could be using some trigonometry here to help find whatever we are looking for. But what are we going to be looking for? So in our equation for the big triangle, we have the variables X and H here. And X and H are present here, but our Y is not really present in our equation here, so we don't really need the Y. So let's take the equation that does not concern for the Y. So just that's for X and H. So if you're not familiar with trigonometry equations, or you need some help because you forgot about it, the way I learned trigonometry to memorize it is the phrase SOHCAHTOA, where the first letter of each kind of small phrase, SOHCA and TOA, is the type of trigonometry you'll do. So is the S is sine, the C in ka is cosine, and the T tangent. And then the two letters behind each letter, but behind each type of trigonometry shows the sides that we need to use. So for example, the SO, it has S for sine, and then OH. O means opposite from the side, from the angle that you use, and then H is hypotenuse. And then for K, it's A is the adjacent side to the angle, and H is the hypotenuse. And then TOA is the opposite side of the angle and the adjacent side to the angle. So we don't want to use our Y, and our Y is the hypotenuse. So we want to use whichever of these three trig functions does not have the hypotenuse, and it is TOA or tangent. So we're going to use tangent to solve or get closer to solving our problem. So tangent of an angle, so tangent of our 65 degrees, this is the angle that we have. So we need to look at our angle. Is it going to be equal to the opposite over the adjacent angle? So our opposite angle is, from our 65 degrees, what is directly opposite on the other side of it would be our H. And then our adjacent side to our 65 degrees would be 1/2 x. So we have this equation here, and I can rewrite it by multiplying 1/2 x on both sides. So we have tangent 65 degrees times x over 2, that is 1/2 x rewritten, is equal to h. And now we can plug this in, or equal to h, into this equation here. So instead of writing h in this equation here, we can write tangent 65 degrees times x over 2. So now we have our area equation more written out. And in the beginning I forgot to do this, but we already have our area known, right? So instead of a, of course, we can write our known area, which is 11.5. So that is necessary to solve our equation. Sorry that I forgot about that in the beginning. But now we can solve further, and we only have one variable appearing here, so we can in fact start solving for x. So first thing, of course, to do necessary is to simplify. So I'll simplify the right side. Let's see how we can do that. So this 1/2 x times x over 2, these are the same things, right? 1/2 x is equal to x over 2, so it's like x over 2 squared. So I'll just write it as that for now, keep it simple, times tangent of 65 degrees. So then our 11.5 is equal to x over 2 squared. So whenever you square a fraction, it's the same thing as squaring the top just by itself and the bottom by itself. So for example, our x over 2 squared will become x squared over 2 squared. So that's 4 times, and now I'm going to still multiply it by tangent of 65 degrees to make it still neat a little. And now I will divide both sides by tangent 65 over 4, because if you see here, this is getting multiplied to this, so we can transfer the divided by 4 onto this tangent 65 over 4 and remove it here. And I'm doing this because my goal is to get x by itself, so I can divide tangent 65 over 4 onto both sides, so it'll cancel out here. And then on the left side, if you divide by something, you can multiply by the reciprocal, so it'll be times 4 over tangent 65, which is 40 times 11.5 is 46. So 46 divided by tangent 65 is equal to x squared. So I'm going to make a little more space here so I can work more. Oops. And now to find x, all we have to do is square root. So our x is equal to, remember, whenever you square root when you're trying to solve for a variable, you're always going to have a positive and a negative answer. However, if you look at the context of the problem, we're going to find a side length value, and the value or the length of a side is never going to be negative, right? It's not possible. So I'm going to just disregard the negative here. It should be here, but I'm going to disregard it because it cannot be the answer. So I'm going to just write the positive value, which is square root of 46 over tangent 65. And now it's calculator time. And I'm going to plug that in, and then hopefully the answer we get will be one of the 4 options here. So let's see. So if you plug this into your calculator, you're going to get 4.6314 and so on variables. And does that look like any of the answers that's possible? Yes, it does. It looks like C. So the correct answer is C, 4.6 centimeters rounded. So that is the final answer. Thank you for watching this video. I hope you enjoyed it, and see you next time. Bye.